Hey, math people. Are you cramming for the SAT? You just clicked a video that was named something about cramming the SAT. I didn't name it yet. You're cramming for the SAT, and I'm not here to shame you about that. I get it. It's not easy. This is not a fun part of your life, and especially now, if you're watching this in 2020, yikes, you're probably like a senior and your SAT was probably canceled like a million times over, and now you're just kind of rolling with the punches and doing what you can. Okay, so I just want to make a video for you. Just the crammers out there, year in, year out, but especially 2020. I was initially going to just do problems like per subject or per topic area. So like, oh, okay, let's do a linear, let's do a quadratic, let's do a rational, just to make sure you can hit all those topics. But I actually encountered practice test number 10. They probably uploaded this in the last like 2 years or so. It wasn't around when I first started my SAT videos. And I really liked the non-calc for it. So I'm just going to do the whole non-calc for this as swiftly as I can in terms of my explanations. I'm not here to flex on you guys. I'm not going to just do these super hyper mega fast and then just that's it, no explanation. No, I want to do them nice and swift. So my suggestion is to time yourself. Do this right now. Pause me from talking and do practice test number 10. Do the non-calc and time yourself, rigorously, all those things, yada yada. The best way to cram is honestly to practice. Just do practice problems. Don't try to like learn anything new at this point, like watching videos on how to solve rational expressions. No, forget that. Just do practice. That's the best way to cram. Practice. And to watch some of my other videos, knowing the formula, stuff like that, knowing what's going to be on the assessment. So without any further ado, let's hit this. So pause your video, try out practice test number 10, non-calc, 25 minutes, 20 questions. I will wait 3 seconds because you can pause me. Okay, so welcome back. If you just awkwardly stared at me, you didn't do what I asked. But if you actually went and did this, good for you. So let's get to it. I haven't done these. I just kind of scrolled through them. I'm just gonna have the key to the right, just so that I'm just gonna double check. It gives me a little bit of confidence, reassurance, just so that I don't accidentally deliver any wrong information. So looking at number 1, 10-second problem. I gotta find my pen. Here I am. You're just solving. Just sneak this z on over. This is gonna look not too pretty, but you're gonna have z plus 1 is equal to 0. Subtract that 1. You get z is equal to -1. The first problem on the SAT should always be wicked fast. Get it done in under 20 seconds. Usually something gonna be linear. Usually, not always, but it's usually gonna be linear. The first 3 questions are usually always fairly quick and easy. So yeah, that was B. Looking at 2, words. Words. Let's just try to extract what we need here. So TV's $300. I see this initial payment 60 and weekly payments of 30. Okay, well, you want to get up to 300, and you have this initial payment of 60 plus the 30s each. Whatever the increment is each week. So with reading through this, let's just kind of process of elimination this. Here we make no reference of the initial 60. Here this doesn't make any sense. You shouldn't be subtracting off. Like you owe, you start with -60 and you have to work your way up to $360 for this TV. That doesn't make any sense. D doesn't make any sense either. It's flip-flopping your y-intercept and your slope there. You're not going up by 60 each week in terms of how much you have to pay. This is classic mx plus b, guys. mx plus b. You got to know a few formulas on the SAT. You should watch my video on the formulas for that. But y is equal to mx plus b. The heart of algebra is like a third of the SAT, math SAT. It's y is equal to mx plus b stuff. So know that m represents your rate of change. Know that b starts is your starting value, your initial amount. If you know that much, you're going to get so many questions right. Because I mean, literally looking at the very next one, 3, without even looking at it, I'm looking at the final answers. Know your mx plus b. So here, I'm not even going to read. Blah. It's very clear what's going on here. I have a table. Come up with the equation. Very clear. So b represents your y-intercept, your starting value. So D is out of question because this is not your starting value. This is your, this is 16.94 is the y component when x is equal to 5. So that's not your y-intercept here. These guys don't even have y-intercepts. So the answer is just B. Yeah, the answer is just B. The reason why, and you could go back, right? You could go backwards and hunt this down, and I'll show some of the math for that for the sake of that. And this would be probably a problem on the SAT, where I would do exactly what I just did, and then continue with the test, and then circle back to it at the end if I want to just verify the math. Because I'm telling you this answer, I mean, I know the answer is B. I'm looking at the key as well, but just based on the way that this problem is set up, it's very clear to me that it's B. But let's actually do some of the math. This is in terms of the starting value, we need the slope first. So the way that we would find slope, slope formula is m is equal to change in y over change in x. So if you wanted to sit there and go through this calculation, you can. It's a thing you can do. So I'm just going to choose, this will be my first order pair and this will be my second. I'm just going to use the first two. I hope that makes sense. You can use any if you want. So 21.89 minus 16.94. And then this is going to be all over 10 minus 5. You can go through the slow and tedious calculations here. What you're going to get is 99 cents. It's telling you that's what you're going to get. And I can just see that that's what's going to come out of here. You're going to get like 4.95 up top, and you're going to get 5 down below. And that's 99 cents. That's the slope. So like right off the bat, we can definitely kind of cancel those two for that reason. Now what you could do is you can use the slope, go back 5 iterations to figure out the y-intercept, but there's only one choice here, right? Because we're on an x value of 5. We got to go to an x value of 0. There's only one choice here with a not, we have 2 with y-intercepts of 0, and then we have one choice with a y-intercept of 16.94, which is not correct. That's what happens at x value of 5. Very clearly here, if I go back 99 cents 5 times over, or $4.95, what that is, you're going to get $11.99. So know your y is equal to mx plus b. This problem, it can be as quick as 20 seconds if you know that. You know it really well, and you can tell that that's what it's asking. Number 4, another line. I don't really like reading, but I'm going to try to extract what. Okay, so here's a good hint, a good little tip and trick. If you watch my tip and trick video, read the question first. How much greater is the height of the Doric column that has a base of 5 than the height of a Doric column that has a base of 2? Okay, my guess is so we're just looking at the outputs at 2 and at 5. So I didn't read any of this. So we want to just figure out how much greater. So we're just going to find the difference. So I see that we're 35 at 5, and we're 14 at 2. So can I math? What is that? 21. So it should be C. Where's my cursor? Hello? Oh, there I am. Yeah. So 21. Read the question first, because sometimes there's going to be like this problem has like just ridiculous like context to it. I don't know what a Doric column is. Maybe somebody can tell me what it is. Maybe I should know what it is. I'm not sure. Anyways, just read the question first. It's clear what it's asking. We find the difference. That's how you figure out how much greater one is when compared to another. So again, another line. Know your linear equations. Heart of algebra, like 33%-ish of the test, which is mostly lines. Okay, so which of the following is equivalent to the expression? The way that you can think about square roots, it's just square root of 9 times the square root of x squared. Here they cancel. Square root of 9 is 3, so you get 3x, and that's the solution. I feel like this is a bit of a missed opportunity because you know what a lot of kids do here? They'll cancel this out, and they'll just say 9x. And I don't see 9x here, so this is not right, by the way. So I feel like, I don't know, a bit of a missed opportunity. Maybe that's what they're going for with B, is that some kids will just take the square root of 9 and then keep the x squared. So if you had it set up like this, square root of 9 times x squared, then B would be the right choice. But it's the x squared is underneath the radical as well, so therefore it's A. Yeah. Looking at 6, This is a rational expression. Okay, the way that we solve rational expressions, you want to multiply by the least common multiple. Blah, blah, blah. Let's multiply by this denominator and get rid of the fraction. Okay, so I'm going to multiply this whole thing by x minus 1. And what's nice is on the left side they cancel, right? When you kind of distribute this into both the left and the right. And then on the right, it's going to be negative 2 times this x minus 1. So we're going to have x squared minus 1 is equal to negative 2 times x minus 1. The way that we solve quadratics is you set it equal to 0 and you look to factor or use quadratic formula, which is a last resort. So we're going to have x squared minus 1 is equal to negative 2x plus 2. Sneak these guys on over to the left. So you're going to get x squared plus 2x minus 3 is equal to 0. And let's hope factoring works. What multiplies into negative 3 and adds into 2? That's positive 3 and negative 1. So you're going to get solutions of negative 3 and 1. And it's very easy to just say, okay, well, then the answer is D. That's it. I figured it out. No. Anytime you encounter a rational equation or radical equation. So rational just means fraction, and radical means square root. There's a square root with an equation. We haven't encountered that yet. You should check for extraneous solutions, which are like fake answers. So you should plug these back in to see if they work. Because I can tell you right now, if you plug in this 1, I'll just show you what happens when you plug in a 1 to x. You're going to get 1 squared, that's a squared, minus 1 over 1 minus 1 is equal to negative 2. Think about this, guys. 1 squared is 1. 1 minus 1 is 0. 1 minus 1 is 0. You get 0 over 0 is equal to negative 2. What the heck? That's called an extraneous solution. So 1 is not going to be your answer here. It's just going to be 3. If you do plug in negative 3. If you do plug in a negative 3, it will work out. It's very rare. I can't think of any situation where you get 2 extraneous solutions. Maybe it happens, but I doubt they'll do that to you on the SAT. But they certainly would give you an equation with 1 extraneous. That I can see. It's very, I would imagine 50%, maybe plus, maybe somewhere around, 50% of students probably would select D here without checking for extraneous solutions. So rationals, which is fractions, and radicals, which is square roots. Check for extraneous. Now, I guess I should just check to make sure that's right. Yeah, it's good. Okay. Looking at 7. This one's a bit of a meme. I don't know. It's just saying, what's the y-intercept? 4. So when you see this notation, f of 0, this just means what's your y value at that moment, and your y value at that moment is 4, and then that's that. So you would say like f of 0 is equal to 4. Something minor though, let's just talk about. So remember, the point of this video is not to flex on you guys and do this as fast as possible. I want to also teach some math at the same time. This is to me, this looks like an exponential curve. And what you should know about exponential curves is this following setup. A times b to the power of x. A is your y-intercept, so in this case it'd be 4. And b is your growth factor, growth or decay factor. It's what you're multiplying by each time. It's an exponential. When you have a repeated multiplication, you get an exponential curve, which is you kind of level out for a bit, and then all of a sudden it spikes upward, which is what's going on here. So you do need to know the exponential curve. You need to know this a times b to the power of x. I'm sure there's going to be another opportunity of that later to circle back to that. Geometry, not a huge portion of the SAT, but it's still on there nonetheless. On the figure, point B, okay. What is the value of 3x? All right. We know that there's 180 degrees in a full straight angle. And we know that this is 90, so therefore the other side must be 90. So we're just going to do x plus 2x plus 2x is equal to 90 and solve. This is going to be 5x is equal to 90. And divide both sides by 5. Man, what is that? Shoot. So dividing this by 5, dividing this by 5. 100 divided by 5 is 20. So 19 divided by 5 is 18. Okay. I woke up like an hour ago. Give me a break here. Yeah, 18 times 5 is 90. So this is the non-calculator. You'd have to do that on the fly. So we get an x value of 18, and sure enough, people are going to circle 18. They're going to be like, okay, that's the answer. But that's not what it's asking. It's saying, what is the value of 3x? So if x is equal to 18, 3x is going to equal 3 times 18, which, what is that? 54, I want to say, right? Yeah, 8 times 3 is 24, and then 30 plus 24 is 54. Okay, the hardest part for that was me. The hardest part of that for me was the arithmetic. So C is the right choice. Arithmetic being like adding and multiplying and stuff like that. We get so accustomed to using calculators these days, right? All right, so coming up with equations of lines. Know your mx plus b. There's 2 more. There's point slope in standard form. You should know point slope, but standard form, I don't know. Here's the thing. These answers are in standard form. They're in this ax plus by is equal to c. I don't know. Just convert. Here's my suggestion. Convert to slope intercept anytime this happens. That's my suggestion. So when I come up with the equation of this line, it's down 1 over 1, down 1 over 1. So that's a slope of -1. And I have a y-intercept of -4. So I know my equation is y is equal to -x plus 4. Oh no, that's not a choice here, right? They're all in standard form. Not a big deal. Just convert it to standard form. Move this x on over. You get x plus y is equal to 4. And hey, look at that. The answer is D. X plus y, -x minus 4. The y-intercept is a -4. I looked smooth until that error, but this should have been a -4. So anyways, it'll be x plus y is equal to -4. The y-intercept here is on -4. So anyway, move this x on over. You get x plus y is equal to -4. And that is choice C. 9 is C. Yeah. So take away, know your slope intercept, and be willing to convert to standard form. If you happen to be a little fancy and you know standard form stuff, you're probably not even watching this video in the first place. Why would you be watching a cramming SAT video? You probably already know everything you need to know. So great, good on you if you know standard form of lines. I'm not going to hold you to that. All right, 10. It's quadratic. Know your quadratics. So in terms of just general quadratics, you should know 3 forms. You should know ax squared plus bx plus c. This is standard form of a quadratic. You should know a times x minus h all squared plus k. This is vertex form of a quadratic. What's the other one? A times x minus p times x minus q. This one is intercept form or factored form of a quadratic. They all have their advantages, but I think you'll see standard form the most. Standard form is just in its simplified algebraic form. Vertex form, h and k, that allow you to do vertical and horizontal shifts, right? So if k value will be your up and down, and your h value will be your left and right shift. And then P and Q, these are just your x-intercepts. That's what those represent. And what A does every time, it's your stretch or compress factor. So if A is really, really, really big, it's stretched out and it's super skinny. And if A is small, like a fraction, like half, it compresses it and it starts to get wider. All right, so what's the value of K? K is just the intercept, and that's easy. For standard form, the C value is your y-intercept. You can plug in 0 to both of these terms and they go away. So the answer is just 12. Yep. Okay, 11. Know your equations of circles. I can already tell. Yeah, I mean you can read, right? But my eyes went to the math. These are all equations of circles, so it's x minus h squared plus y minus k squared is equal to r squared. H and k is your left and right. So left and right, up and down. H is left, right. K is up, down. And then r is your radius. So just know that it's r squared. It's equal to r squared. It's not equal to r. So when it says here radius of 2, well, r is equal to 2, sure, but it's 2 squared, so 4. So right now, no and no. Get out of here, C and D. Okay, so you have to cross through 5, 7. So that would be right 5, up 7. And looking at these choices here, The way they kind of work counterintuitively, h and k. Think of it this way, all right? This is the best way of thinking about it. The formula is defaultly negative. You have h minus, or x minus h, and you have y minus k, okay? By default, there are minus signs here. So when you plug on in a positive 5, it's going to have in the equation an x minus 5. And when you plug on in a positive 7 for this k value, that's the y value, which is up, down, by default, it's still a minus. When you plug in a negative, it would be a minus a negative to make it a positive. So with that said, choice A is your answer, and for B, this would be -5 and -7, which, you know, if you have a minus a negative, you would end up getting a positive. So that's a little sneaky with that said, but just know the formula. There's not many formulas you should know. Watch my formula video, and this is one of them. So this is just directly testing you on that. Okay, 12. Was my face in the way? I hope my face wasn't in the way. Anyway, 12. Looking at this guy, I'm only going to do a one and done on this, just so you guys know. In the figure above, okay, so you have this triangle ABC is similar to triangle DEF. Okay. What is the value of the cosine of angle E? These are similar triangles, which means the ratios are the same. For the trig ratios are the same that we're going to be creating, the fractions. So we just go back to ABC, and we note that cosine, you should know SOHCAHTOA. So there's not many trig-related problems, but there are maybe 3 or so at most. So SOHCAHTOA, if we want to set up a cosine ratio, it's going to be adjacent over hypotenuse. So the adjacent is not opposite to it. Adjacent is going to be 12 over the hypotenuse, which is the longest one always, 13. So it's going to be 12 over 13. And that is choice B. Yeah, no SOHCAHTOA for the trig ones for sure. SOHCAHTOA. Do you need to know like crazy trig identities? No. But SOHCAHTOA you do need to know. Okay, looking at 13, we have another quadratic. Find the intercepts, find the distance between the intercepts. So we should get this in an intercept form. Let's factor this. What multiplies into 4 and adds into 5? Positive 4, positive 1. So the way we find the x-intercepts is we set this equal to 0 and solve. Set these both equal to 0 using what's called zero product property, which you don't need to know. So you have x plus 4 is equal to 0, x plus 1 is equal to 0. You have an intercept at -4 and at -1. So when it's asking what is the distance between the intercepts, well, what is the distance between -4 and -1? It's 3. So know your quadratic forms. There are 3 quadratic forms. Know the usefulness of all 3. I mentioned earlier, so number 14, if you have a radical equation, check for extraneous solutions. Radical and rational. This is a radical equation. I would not be surprised if I don't know, I haven't solved it yet, but I wouldn't be surprised if there's an extraneous solution here. So the way we solve these, square both sides, get rid of that radical. So you get 4x is equal to x minus 3 all squared. This is a quadratic, so multiply this out and set it equal to 0. So I'll just show all my work here. This is x minus 3 times x minus 3, still equal to 4x. This is going to be x squared minus 6x plus 9. Right? Just by FOILing. So I did this. Okay. What else? Something got stuck in my throat. Move this 4x on over, and you get 0 is equal to x squared minus 10x. What else? Plus 9. This should be factorable. It is. So what two numbers multiply into 9 and add into -10? Well, you got the x minus 1 and you got the x minus 9. So you get two solutions here. You get x is equal to 1 and x is equal to 9. Great. You guys can't see the answer. I'll just scroll down a little bit. But here's the thing. I'm sure maybe one of them's extraneous. Maybe not. Let's plug them in and find out. If you plug in a 1, you're going to get the square root of 4 is equal to 1 minus 3. And would you look at that? Square root of 4 is 2. 1 minus 3 is negative 2. No. No. So it looks to me like 1's going to be your extraneous solution. If you plug in 9, I'll just show what happens when you plug in 9. You'll get 4 times 9, which is 36. So the square root of 36 is equal to 9 minus 3. Huh. Yeah, I got to get a new pad. I'm using like a really small pad right now. I got a bigger pad at work. Because right now we're teaching remotely. And it's nice to have a pad to do pencil math. Yeah. Instead with a mouse. You get 6 is equal to 6. Yeah, that's a thing. So 1 is the bad guy. We don't like 1, we like 9. So it's just 2. 2 only. So the answer choice that is correct is B. Answer B. So check for extraneous with radicals and rationals. 15's fun. It's a system. There's lots of systems on the SAT. I'm surprised. I think this is our first one, maybe. So I'm surprised it's our first one. Maybe you'll see more on the non-calc for this particular test. So in the system of equations above, a is a constant. For which values does of a does the system have no solution? A system has no solutions when you have two perfectly parallel. When you have two perfectly parallel lines, as you can see, that's not at all parallel. I'm going to do one more attempt at it with this little pad. There we go. Pretend those are perfectly parallel. And they never touch. No solutions, no intersections. So what we want to do is we want to get them to have the same slope. So mx plus b, guys, know that one. Know y is equal to mx plus b. That is the way to go. I'm going to move this 3x on over. So I'm going to get y is equal to 3x plus 6. Okay. So solving for y on this guy, we're going to get 2y is equal to negative ax plus 4. And then divide everything by 2. So you're going to get y is equal to negative a over 2x plus 2. I don't care about the y-intercept. This is what I care about. I care about the slopes. In order for two lines to never touch, you need to have the same slopes, different y-intercepts. These are certainly different y-intercepts. So you'll note here, I want to set the pinks equal to each other. I want to set this 3 equal to this negative a over 2. So 3 is equal to negative a over 2. This is a pretty simple equation to solve for. Multiply both sides by negative 2. So you get negative 6 is equal to a, bringing you to choice A as a final answer, which I will confirm is the final answer. So in terms of systems, when two lines, same slope, different y-intercept, they never touch. When you have two lines, same slope, same y-intercept, they have infinitely many solutions. It's the same line. And otherwise, you'll get always one solution for two linear equations. Two lines can only ever touch once, right? You can't have like two lines touching like 2 times or 3 times. It's either 0, once, or forever. All right, so free response question time. Fun stuff. Hopefully you guys already know the stuff ahead of time before you walk into the SAT. So you can write your answers fractions. I don't think you get any negative answers ever. Yeah, you don't. So there's no negative sign, right? You can't. So if you get a negative, like, just redo the problem if you have the time for it. Okay, so I think 5 more problems left. When you have answers to work off of, that's when you're allowed to skip some of the reading because you can just look off the answers. However, when you have no answers to work off of, you gotta read the problem and you already did enough reading in parts 1 and 2. But sorry, we got to read this. Okay, but we could start with the last question first. If the total shipping was 47,000 and 3,000 units were shipped to the farther location, so I'm assuming F is farther, how many units were shipped to the closer? So I'm assuming T is closer, and total shipping is probably T. All right, so I didn't have to read the first sentence. Good. What I could do is I have 3,000 for F, that's farther, and I have 47,000 for T. I can just do, I'm still in pink, I can just do 47,000 is equal to, so the 3,000 is associated with the F, 5C plus 12 times 3,000. Okay, this on the right is 36,000. So I'm just going to subtract 30. I'm just going to do this in one kind of fell sweep. Minus 36,000. 47 minus 36 is a number. It's 11,000. That's equal to 5C. Divided both sides by 5. And here's the thing. You don't have any answers to work off of, so you got to know how to do this by hand. I know that 10,000 divided by 5 is 2,000. And so I know I'm going to have it 2. And I know 1,000 divided by 5 is 200. So it's going to be 2,200. And man, I'm so used to calculators. It's kind of scary, like a little too scary. I have Brain Age on my DSi, my Nintendo DSi. And I started playing Brain Age again to like work on my arithmetic as a math teacher. Isn't that crazy? Anyways, yeah, that is the right answer. Read the last sentence first. Figure out what the question's really asking, right? Read the question. Forget about some of the disclaimers at the start. And then go back to them if necessary. Okay, looking at 17. So the way we solve absolute value equations, you set the positive version of the absolute value equal to whatever the number is. So 2x plus 1 is equal to 5. Okay, this is kind of expected. But then you set the negative version of the absolute valued expression equal to 5. Right, because that's what an absolute value does. An absolute value makes it always positive. So we got to consider the negative event, kind of, where if just this inner piece was negative, right? Because if this inner piece was the perfect negative version of it, the absolute values would just make it positive. So we're going to solve both of these equations. And I guess that's kind of one of the obstacles is solving an absolute value equation, which, I don't know, you don't do too much of, right? You get negative 2x minus 1 is equal to 5. You move that 1 on over, you get negative 2x is equal to 6. X is going to equal to negative 3. So when you plug these in, it won't matter which, the absolute values, it doesn't matter which one you plug in. I'll plug this 2 and negative 3 in to this expression in both different ways to show you you're going to get the same number. So what we're doing is we're taking the solutions and we're plugging it into this. So if I were to say A is equal to 2, you're going to get the absolute value of 2 minus a negative 3. Okay, so 2 minus a negative 3 is 5. The absolute value of 5 is 5. Let's just say I plugged it in the other way. It's fine. All's good. You get negative 3 minus 2. So negative 3 minus 2 is negative 5. The absolute value of negative 5 is still 5. You get 5 either way. So the answer to 17, did I skip 16? No, I did 16. I don't know what's going on. Maybe I should have woken up more before doing this. Anyway, 17, you end up getting 5. That's the right answer. Okay. Juan purchased... Okay, I'm going to read the question at the end. What is the value of A? Dang it. I read the last sentence first. I got to read the whole thing. Sorry. Sometimes it just does work out that way. So Juan purchased an antique that has a value of 200 at the time of purchase. Each year, its value, okay, look at this, is estimated to increase at 10% over its value. I have a hard time reading the previous year. I know what's going on here because I'm already thinking about how I want to explain this. I mentioned earlier the exponential a times b to the power of x. You should know this. A is the starting value. B is the growth factor. Now, what's a little unfortunate about this problem is that they're kind of using A as this growth factor, whatever. The way that repeated multiplication works, you end up getting an exponential. It looks to me like in this problem, we have this starting value of 200. We have to figure out what our growth rate is. If you're increasing by 10% every time, here's the way I want you to think about this. You start at 100% of your value. That's what you start at. Like right at the moment you start this little endeavor, the moment Juan purchased this antique, it's at 100% of its value. But it increases 10% each year. So after the first year, you're adding a 10. that's how much you go up by. So 100% plus 10% is 110%. Now, we don't use percents when we're talking about growth factors as multiplication. You don't really multiply by 110%. You got to convert that to a decimal. And the way you convert it to a decimal is you move the decimal place on over twice. This is a growth factor of 1.1. You are 1.1 times what you were the previous year. So that's what you're going up by every time. You're multiplying by 1.1. And when it's asking the estimated value of the antique in dollars, 2 years after the purchase can be represented by 200 times A, where A is a constant. You just have to figure out what A is. So you multiply by this 1.1 twice, so you're squaring it. That's where the exponential comes in, right? Hopefully you're making the connection between these forms. We just have to figure out what this number is. So the 200 you'll see is just still there. We need to figure out what this A value is, which is this 1.1 squared. And the way that we would kind of work out this math, we would say, okay, well, 1.1 times 1.1, 11 times 11 is 121. So this is 1.21. And that's actually your final answer. This one was a little tough. You know, it's exponential functions are taught commonly freshman year, so you may not have seen this for a little bit of time. So no, that's how percents work, though, with growth rates. Okay. Last two. And we're doing fine on time. We're going to beat the 40-minute marker. So based on the system of equations, what is the value of 5x plus 5y? Okay, so we have a system here. And I see a shortcut. I see a super clever shortcut. This is going to be great. I'm going to do it the slow way. Let's pretend I didn't see the shortcut. The slow way would be this. You would multiply by, let's solve this by elimination. I'm going to multiply top and bottom by some number to get some elimination. I'm going to multiply top by -3 and bottom by 2. And that would allow me to cancel out my x's. So I'm going to get -6x minus 12y is equal to -3600. And then down below, you're going to get 6x plus 4y is equal to 2600. Okay, the x's cancel. You end up getting, over here, you end up getting a number. You get -8x, or -8y. And that's equal to 36. Okay, so this is 26 minus 36, so you're going to get -1000. Man, what a slow, tedious grind. This way sucks. I want to just do it the fast way. Let's just do it the fast way. If you just add down, just off the bat, big brain this, just jump to the answer, like literally, because you're trying to look for the value of 5x plus 5y. If you just add down right off the bat, screw this nonsense over here, you get 5x. Uh-oh, we're halfway there. You add down on the y's, you get 5y. What the heck? That's what we're looking for. And then 1200 plus 1300, okay, that's 2500. And that's the final answer. Boom. This could potentially, this is a crazy, like, I don't even know. Would you guys consider this problem smart? I'm not sure. Because if we think about this, this problem can be done, and I'm just going to double check the answer. Yeah, that's the right answer. This problem can be done in a matter of 5 seconds, 5 to 10 seconds. Or if you do it the slow way, it might take you 2 to 3 minutes. So I don't know. It's hard to say. I'm going to say kudos to the problem, but at the same time, it feels kind of mean. All right, 20. All right, we're going over 40. Whatever. I'm having fun here. Looking at 20, we have this expression, this u minus t, and then multiply by u squared minus t squared. We want to come up with the expression for it, and we're only given what u plus 5 or u plus t is equal to and what u minus t is equal to. So what we should do is we should rewrite this expression. I'm going to keep the u minus t. We like the u minus t because we see it above. But if you look at this like rightmost expression, this u squared minus t squared, difference of two squares factoring. That's maybe the last kind of thing that I'll talk about here. You should know how to factor in difference of two squares, be able to identify it in like more abstract senses. We know that, and I'm just going to do a random side example. Where am I going to do it? I'm going to do it over here. If I gave you x squared minus 9 and I told you, hey, factor x squared minus 9, It's the difference of two perfect square numbers, and the way that that factor is x plus 3 times x minus 3. In my very sloppy handwriting there. It's a squared minus b squared. It factors to a plus b, a minus b. Anyway, I can do that here. So this will be u minus t, and then u plus t. So now I can just straight on plug in. U plus 5, oh, okay. That's this 5 right here. I have two u minus t's here, so this is going to be a 2, and this is going to be a 2. 2 times 5 is 20. Final answer. Can confirm. Okay, 42 minutes, whatever. We're doing a little bit of more, right? We're not just doing the test. We're doing it swiftly, sure, but we're also teaching a little bit more stuff. So just like general recap stuff. Knowing how to factor is good. Systems of equations, know how to solve those for 19. But look for keen shortcuts. It's a little hard to see, but it was there. Knowing your exponential functions, knowing how to solve absolute value equations, radical equations, rational equations. Linear stuff, lots of lines. Like if you're like, man, okay, absolute value equations, rational equations, too much. Sure, that's only gonna be like one question each. So just no lines, and that's gonna be like a third of the exam. So forget about that other stuff. You only need like a 50% to be college ready. So like, if you would have goofed up on this one and you didn't know the extraneous solution for radicals, whatever, just get all the line equations right. No solutions for systems when they have the same slope and different y-intercepts. Quadratics, knowing all three forms, intercept, standard, the other one, vertex. Knowing the equation of a circle, I guarantee you there's going to be like one circle question, and it's usually just, it's just throwback to the equation itself. The only trig I would really know is SOHCAHTOA and maybe the first Pythag identity, maybe, but really just SOHCAHTOA. 10, what's this? Yeah, knowing your quadratics. 9 was just a line. Don't worry about standard form. Forget about it. Just know your slope intercept and be willing to convert. Okay, there's a little bit of geometry. No like 90 degree, 180 degree angle stuff. Number 5 is order of operations. Please excuse your dear Aunt Sally. Yeah, you should remember that chime from way back when. Knowing intercepts for 7, exponential helped. 6, that's that extraneous solution case. But knowing how to solve rational expressions generally, get rid of the fraction. Multiply by the denominators so that the fraction goes away. Looking at 4, read the last sentence first. Read the question first, and then you can skip some of the jargon there. But knowing lines. Number 4 is a line. Number 3 is a line. Number 2 is a line. Number 1 is also a line, actually. It's a linear equation. So no linear equations. That's really the big thing. It's from freshman year. It's been a little bit of a time jump. You're probably a senior right now, or maybe a junior. I don't know. Whatever the case may be. I'm going to ask you to continue to math on. I will do the same. I'll see you in the next video. Good luck on the SAT if you're taking it really soon. Bye.